1. Okay, stoichiometry, we started this was, we said it was Greek for measuring elements, and that it was going to let us calculate how much stuff we made. So, literally, stoich means element, metry for measuring elements. But if you look up the definitions, it's the calculations of quantities of chemical reactions based on a balanced equation. So you can't do stoichiometry until you can write a balanced equation. That's why we did it in that order. So now we're talking about how much do you make. Last week and a half, we've been working on what you make. Now we're going to figure out how much of it you make. Quantity, how much. So we've got to figure out how we turn balanced equations into numbers we can measure. What does that equation have to do with things we can measure? And you've done most of the math already. Guess what old friend we're bringing back? The bell work should have been a clip. Bowls, yeah. Okay, so when I write a balanced equation like this, okay, I write an equation like this. We balance it by atom, but it doesn't react by atom, does it? So what this equation is saying is that 2 molecules of hydrogen and 1 molecule of oxygen form 2 molecules of water. Isn't that what those numbers really mean? That's what we're balancing. I had H2s. I had two H2s, molecules of H2, and I had molecules of O2. And when I was done, I had new kinds of molecules of H2O. Started off with 3 pieces, ended up with 2 pieces. Now, that works real well here because everything in here is a molecule. But the smallest piece isn't always a molecule, but it doesn't change what we do. So, aluminum oxide decomposes into aluminum and oxygen. Well, I know there's 2 pieces of Al2O3. What kind of piece is Al2O3? Okay, is it element or compound? Compound. Ionic or molecular? Ionic. So the smallest piece of ionic compound is a formula unit. Because all we have is, this is where we call it a formula unit because we write the formula where the charge is equal 0. That's the unit we talk about. That's why it's called a formula unit. Because it's not really a unit. They don't really stick together. When you melt them, they go separate ways. Not like a molecule. That form for what kind of piece is aluminum? Is an element, yeah, and the smallest piece of that element is an atom. So 4 atoms of aluminum, and that's the plus sign. 3, oxygen's an element, but it's diatomic, so it is a molecule. So now we're doing quantity. We're talking about how many pieces. But individual pieces are a problem. They're too hard to count. Okay? So let's look at it a little bit differently. Don't copy this down. You spend more time writing, and I don't want you to focus on the writing. I want to focus on the big idea. Okay, there's our equation. And we said 2 molecules of oxygen and 2 molecules of hydrogen, 1 molecule of oxygen make 2 molecules of water, right? Is this true? would 24 molecules of hydrogen and 12 molecules of oxygen form 24 molecules of water? I just do it 12 times, right? What if I did it a bigger number of times? What if I did it 1,000,000 times? Would 2,000,000 molecules of hydrogen and 1,000,000 molecules of oxygen make 2,000,000 molecules of water? It's ratios. Well, let's talk about a really big number. What if I did it Avogadro's number of times? What if I did Avogadro's numbers of times? Would it still be true? If I do it Avogadro's numbers of times, it would still be true. Hey, no. It's even easier than that. I have a shorter way of writing 2 times Avogadro's number of molecules of hydrogen, because Avogadro's number of molecules of hydrogen is a mole of hydrogen. So we can write this as 2 moles of hydrogen and 1 mole of oxygen makes 2 moles of water. We can read these equations in moles. Because they happen particles at a time, we can do them in groups of particles at a time. We can do it moles at a time. We can read these equations in moles. So that's what we need to do. We need to be able to write these things in terms of moles. So what would this equation be in terms of moles? Okay, so you don't want to forget it when you get home tonight and have to write it down. That would be 2, oops, my pen doesn't want to work. That's 2 moles. The Al2O3 form 4 moles of Al and 3 moles of O2. Yeah, that's really easy. Oh, not much harder. So what we have learned from this is the coefficients tell us the number of moles. Coefficients are, we can read the coefficients in moles. We can read it in particles. We can read it in moles. Everybody okay at that? Hey. So according to my equation, every time I use 2 moles of Al2O3, I make 3 moles of O2. So those are equivalent. If I use up this, I make that. So I can write 2 moles of Al2O3 for every 3 moles of O2. Or I can write 3 moles of O2 for every 2 moles of Al2O3. I can put either one on top because they're equivalent. And I can make 4 more out of this equation. Those are the ones going between aluminum oxide and oxygen. What about aluminum and oxygen? Could I make a conversion factors between aluminum and oxygen? Well, I could write, well, for every 4 moles of aluminum, there are 3 moles of oxygen. I can use any of those coefficients to make a ratio with any of the other ones. Does that make sense? And why we do that? Well, because this here, I started off with talking about how much I made, and I ended up talking about how much I started with. I'm figuring out the quantities involved in a chemical reaction in moles. So, if 12.3 moles of aluminum oxide react, how many moles of oxygen will form? So what unit do I want to get rid of? Moles of Al2O3. Where's it got to go? On the bottom. Now, in the past, when we had moles on the bottom, we could change to grams or liters, or this one, formula units. Heck, I could have gone to ions in there, but grams, liters, formula units, right? But now they don't ask me about anything about aluminum oxide. They ask me about oxygen. So if they ask me about a different chemical, I can only do it in moles. And according to my balanced equation, 3 moles of O2 for every 2 moles of Al2O3. So push some buttons. 12.3 times 3 divided by 2. I get 18.45. I had 3 sig figs in 12.3. What about the 2 and the 3? Is there only 1 sig fig there? You get those by counting, don't you? They're whole pieces. So those are unlimited. So that gives me 3 unlimited and unlimited. So that is 3. So 18.5 moles of oxygen. So that's 75% of this chapter right there. All you got to do is add your bell work to that. So tonight you're going to practice mole to mole conversion. Should be pretty easy. Tomorrow we're going to add all the other pieces to it.